In the name of God. Hi, ladies and gentlemen. Good morning. A very warm welcome to today's international workshop on the Urmia Lake. My name is Hojjet Mianabadi, research scholar at Water Diplomacy Program at TUFTS University and PhD candidate at TU University in the Netherlands. On behalf of organizers, I'd like also welcome to all audiences from around the world through all online webinar guests in this two-day workshop. Firstly, I appreciate all organizers, Water Diplomacy Programs, TUFTS Institute of the Environment, and MIT, including Iranian Studies Group. In addition, we would like to appreciate our scientific sponsor, which I say in alphabetical order. Geological Survey of Iran, MIT Water Club, UNDP, University of Tabriz, Urmia Lake Restoration Program, and Water Engineering Research Institute of Tarbiyat Mudarris University in Iran. It's our pleasure to mention that today we have more than 23 guests and panelist institutions. The main question of this workshop is that, can water diplomacy framework enable a new future for Urmia Lake in Iran? I hope we will have in-depth and useful discussion and talk about this issue. Before starting our workshop, I have some small and quick announcements. You can follow us on Twitter by using hashtag Urmia Lake, or you can tweet to the Urmia Lake account. And this event will be posted in YouTube by MIT, ISG Group, and Thai accounts. Let me start our workshop, and I'm now inviting Professor Shafiq Islam, the Director of Water Diplomacy Program, to welcome an introductory comment. Professor Islam is Professor of Civil and Environmental Engineering and Professor of Water Diplomacy at the Fletcher School of Law and Diplomacy at Tufts University.
Thank you, Hojjat. I think before I start, I think I must acknowledge the serious work that Hojjat and Mahdi did for the last several months to put it together. This is a wonderful beginning, and welcome you all. You came from very far away places, and I was trying to get really what is the actual distance. It's probably several thousand miles, but that's not the point. I think this is also global because we are using webinar to include participants from Europe to west coast of the US. But more importantly, is what we want to do today really is a very ambitious agenda that can water diplomacy enable a new future. So, and it's very carefully chosen. We are not saying that it is possible. Is it possible to at least enable certain things? So what does enable mean? We will continue this conversation. If you look at the top of this really slide, what we said that we are looking for a reframing of the problem. And what does reframing mean? We'll talk about this in a few minutes. And agenda is very tight, so I'll not take very long. I think what we would like to do really, I would like to introduce Anja Danielson. She is also one of the co-hosts of our program for TUFTS Institute of Environment, to give a brief welcome to you. And then we will spend about 30 seconds for each of us just to introduce ourselves. And then I will take 5 minutes just to introduce 2 slides, and then we will start. So with that, Anja, please.
Let me introduce Dr. Anja. Dr. Anja is the administrative doctor at the Graduate Interdisciplinary Water System Science and Society, WSSS program. Dr. Anja, thank you.
Good morning. I'm so pleased to see you all here at Tufts University this morning. And I want to thank Hoyat and Mahdi too for all the effort that they put into. And I wanted to say how much we appreciate that the two of you have been visiting scholars here at Tufts University and at the Tufts Institute of the Environment. You have brought so much new thinking and so much dynamic input to the Institute and to the research at Tufts University. We're really, really pleased that you were able to be here, and we're hoping that this visit from the two of them will carry into the future and lead to many other collaborations. At Tufts University, we were really aware of these interdisciplinary, very complex environmental issues. And when I think about issues surrounding wetlands like the Urmia Lake, I think about the global ecology, how we depend on that ecology. And I would like to read a few questions, two passages from the book by Alan Weisman that's called Countdown. How much ecosystem is required to maintain human life? Or what species or ecological processes are essential to our survival? I think that is really the core question. And the wetlands in the area of the world where the Urmia Lake is located are really the cradle of the ecological systems in the world. So this is a global problem. This is not a local problem that we can shove off and think this is in a different part of the world. And that's why I'm so pleased that this international symposium is coming together here at Tufts University. Tufts realized that these really complex problems are important about a long time ago, and about 15 years ago, we started this effort resulting in the foundation, in the forming of the Institute of the Environment, which mission really is to bring together the environmental work from all the disciplines across the university. So we have scholars in the Institute from the medical school, from the veterinary school, from the School of Public Health, from the Fletcher School of Law and Diplomacy, from engineering, and from various social and humanities and sciences in the School of Arts and Sciences. So we have really realized the importance of interdisciplinary work, and this is the second quote that I would like to read before I finish, and that is, a complete answer to such questions demand input from ecologists, geographers, hydrologists, and agronomists, not just engineers and economists. So I think bringing you together here today and showing that this is a collaborative, interdisciplinary effort to basically save the cradle of our ecological systems makes me very happy that we have achieved this. So welcome to Tufts University, and I hope this is a really fruitful workshop. Thanks.
Thank you. Thank you very much. Before starting our workshop, I would like to invite all participants and guests to introduce themselves so briefly. Please.
Good morning, everybody. Firstly, I would like to appreciate Professor Shafir to arrange this workshop on behalf of my Iranian colleagues, and also Mehdi and Hojjat for the dedicated efforts during the last month. I am Saeed Mourid. I am from Tarbiyat Modares University, a faculty member of the main field of my work is water resource management throughout climate change and these issues. And I appreciate to be invited for this workshop, and hopefully we will have a fruitful workshop during these 2 days.
Thank you.
I have to appreciate from the Dr. Shafak for this workshop. I am Askar Askari Muqaddam. I'm a hydrogeologist. I worked about the groundwater modeling, groundwater contamination, groundwater infrastructure, trucks, and so on.
Thank you.
Good morning. I would like to express my very thankful to the Honorable Professor Shafik and all audience. My name is Kamran Zainarzadeh. I'm working in Urmia Lake Research Institute from Urmia University. My main research focuses on irrigation drainage systems and environmental studies.
Thank you very much.
I am Razia Lak. I'm from Research Institute for Earth Sciences, Geological Survey of Iran. I worked about 10 years in Urmia Lake in the subject of sedimentology and hydrogeochemistry.
My name is Jeff Meller. I won't embarrass our with any more accolades. Everyone has appreciated your efforts.
Thank you.
I am a lawyer and a business person, and I have worked in water in various ways around the world, mostly in developing countries, and I'm interested in how the private sector and the public sector can collaborate in addressing some of these issues.
As said, I'm Antje Danielson. I'm the director of the TUFTS Institute of the Environment. I'm a geologist specialized on trace element geochemistry, but in the last few years I have really specialized on bringing colleagues from various disciplines together.
Thank you.
I'm Leonard Miller, and now a fellow with the Advanced Leadership Initiative at Harvard. My background in water is I developed the water permit program for the U.S. Environmental Protection Agency. And at one time I was in charge of water enforcement for all of the United States.
I'm Zoology Ali. I'm a PhD student in sociology at Brandeis University. I work on public space and social science.
I'm Afri Siddiqui. I'm a research scientist at MIT and also a visiting scholar at the Harvard Kennedy School. I'm an engineer by training, and my focus is on understanding quantitative interlinkages between critical sectors of water, food, and energy, and how to better manage these resources in an integrated way.
I'm Amin Dessouli from Johns Hopkins University. I'm a research scientist, and I work on climate change and variability over regional scale.
Thank you.
Oscar Soyan, I'm a professor of peace and conflict research at Uppsala University, Sweden. I'm a visiting professor at TUFTS and MIT Water Diplomacy Program. I will be here in the summer, for the full summer. I work on water issues. I have been working on water issues for the last 25 years. Besides other things, I'm also now presently involved in the Euphrates-Tigris basin diplomacy, but I'm not going to say when and where and how. That's
I'm Mike Fisher. I'm an anthropologist. I teach in the Science Technology Society program at MIT. And I've been interested in Iran for the last 40 years.
My name is James Westcote. With the Al-Khan program for Islamic architecture at MIT, and work on water issues primarily in South Asia and the US, and from a comparative perspective.
Yeah, I'm Shafiq Islam, and if you look at my website, it says water is what I think and do, and that's what I do 24 hours a day, 7 days a week. But I think what is more pleasing here is that if you look around, really, I'm very pleased to see there are a lot of people really whom we meet also regularly, like Jeff and Jim and Afrin. We have something called Boston Water Group. Boston is an interesting place, and Boston, not only that, of course, you are here, we are very pleased to have you here, co-hosted by MIT and TUFTS. Boston Water Group is a group of people, really, we just meet to talk about water every third Tuesday of the month, and it has been going on for 2 years, and several of you are here. In that sense, Boston is a very intellectually charged town, and I'm glad that you are here, and we hope really we'll have some engaging conversation, really, what can be done. The problem for Urmia Lake is not a new problem. There are many other lakes, and I'm sure you know about it. We're very pleased that you are here, and I know that you are in a longer trip. The group really came to California to Shurush. Shurush will join us also at 11:20. So they have looked at several lakes in the US. What can we really do something that is different, that has not been tried? And that's all it's all about. I hope that that is the conversation we'll have today and tomorrow. So welcome again.
Thank you. In the name of God, I'm Mahdi Zarghami. I'm faculty at the University of Tabriz, Iran. And I'm pleased to be here visiting TUFTS, and also at the summer I'm visiting MIT SSRC. And I work on water governance, and I'm so thankful for everybody accepting our invitation. And I'm sure that we will have a constructive day. Thank you again.
Good morning. I'm Hamed Ala Mohammed. I'm a postdoctoral associate at MIT, Civil and Environmental Engineering, and my expertise is mostly in using remote sensing data to study both water and carbon cycle and their interactions, both at global scale and local scale.
Good morning, I'm David Fairman. I'm Managing Director at the Consensus Building Institute here in Cambridge and also in Washington and some other places, and associated with the program on negotiation at Harvard. I had the pleasure of working with Shafiq and Larry Susskind a little bit on water diplomacy. My main line of work is helping stakeholders on sustainable development problems resolve conflict and reach agreements. I've spent a little bit of time in Iran and a little bit of time on lakes. So I'm quite curious about today, and thank you very much for the opportunity to sit in.
Good morning, I'm John Fallon, and I am developing a nonprofit for water rights and sustainability. I'm just interested in water diplomacy.
Good morning, my name is Papatya. I'm a third year PhD student at TUFTS Chemical Engineering Department. And I'm working on wastewater treatment, water filtration in particular, and my PhD project is partially funded by TUFTS Institute of the Environment, and I'm pleased to be participating in the workshop. Thanks for the opportunity.
My name is Susan Miller. I'm a partner of the Advanced Leadership Initiative at Harvard University. I worked for the United States federal government for many, many years in the information technology area.
Hello, my name is Fatima Mdipulova, and thank you, Shafi, for inviting me to this interview workshop. I from Harvard Kennedy School and in the area of water issues in Central Asia. And Central Asia faces the same problem because Aral Sea is just disappeared completely. So, thank you so much.
Hi, my name is Stephanie Galaizzi. I'm from the Stockholm Environment Institute. We work bridging science and policy for environmental management.
Hello, my name is Nolan McCase. I'm an administrator here at the Tufts Institute of the Environment. And again, I'd like to welcome you all to Tufts University.
Hi everyone, my name is Allison Platt, and I'm a second-year master's student in the Urban Environmental Policy and Planning program here at Tufts. I also work at Tufts Institute of the Environment, and I'm very interested in water issues. I am from California and recently flew over Folsom Lake, so very relevant for me.
I'm Fatali Garamani. I'm an engineer by profession. I've been involved in waterworks in Iran for quite some time, and recently, well not recently, quite some time in the United States.
Hi everybody, I'm Mania Hassanzadeh. I have a PhD from ETH University. From Atmospheric and Climate Science Institute, mostly working on atmospheric water cycle. Also, Urmia city is my hometown, and I'm a kind of local. And I have a close connection with the people who are working to preserve the wetlands there. So I'm really happy to be here.
Thank you very much. Very pleased.
I'm Jory Hecht. I'm a PhD candidate in the Environmental and Water Resources Engineering program, and also in the Water Diplomacy program here at Tufts. Prior to studying engineering, I also studied international development, so it's nice to be able to do something where I can join these backgrounds together. And in particular, part of my PhD focuses on planning for society under the uncertainty of climate change and also other factors.
My name is Jake Michael Sarago. I'm a water resource engineering master's student here at Tufts University. Thank you for giving me the opportunity to come sit in and listen to so many professionals and get the expertise and see how things are developed in the working world. I'm from Arizona, so I've been able to see how people develop systems for life and agriculture in the desert. Thanks.
My name is Agustin Boteron. I come from Argentina. I'm a master's student here at Tufts in the Civil and Environmental Engineering department. And I also participate in the water diplomacy group. So I'm very pleased to be here. Thank you.
Hello, my name is Claudine Allian. I have 2 degrees in environmental engineering. My graduate studies is from Columbia University. And I practiced in environmental engineering for over 10 years, 9 years at AECOM, and I'm now transitioning out of a clean tech startup. And both my parents were born and raised in Urmia, so this is an issue near and dear to my heart.
Bye.
Hello everybody, my name is Babak Sharifar. I'm a first-year PhD candidate in city and regional planning at MIT, and my research interest is on the relationship between religion and development planning with a specific focus on Iran.
Yeah. Thank you very much and very warm welcome again. It's my pleasure to invite Dr. Said Morid, professor at Tabiat Madrasa University, to start workshop with his presentation about past, present, and future situation of condition of the Urmia Lake.
Yes, so before we start with Dr. Morid, I just want to introduce two slides so that at least to focus our attention and discussion. I just noticed something I think is quite interesting. If you look at the wall there, it starts with something quite interesting. I thought I have not seen it before, so it's very fresh. So knowledge, in truth, is the greatest sun in the firmament, and life and power are scattered in its beams. This is quite fundamental really in what we will discuss today. And what does knowledge mean? And what is life and power? And these are very intricately coupled. And you will see really as we go through the discussion, the knowledge itself is challenged. And why is it challenged? If you look at this particular slide from 1972 to 2004, these are aerial photographs of remotely sensed part of the Urmia Lake. The claim made here is from the remote sensing images is that over this period, the lake's surface area has reduced 88%. And we have looked, and I have talked to several of you, and we still could not figure out really what is the source of that decline. What is the particular process that is responsible for such a significant reduction? There are competing hypotheses, there are competing data, and we cannot simply agree really what is going on. So that is what would focus our attention really. Can we at least begin to understand really what is the source of the decline and what can be done to essentially at least stop it or make it better. So with that, let's just look at something that basically this I did a reframing of the problem, a workshop that we had at MIT a few days ago. This is a picture I took from home. So this is, if you look at this is really noodles. And noodles and very simple, because all of you have had some of this probably in your lifetime. It's a simple, very long and linear, looks very nice. You buy a packet. And that's a simple system. So the way we understand most of the world is according to those type of systems. Newton's taught us really things are linear. We have Newtonian mechanics. I can tell you really right now it's about 9:25. 9:25 on July 2nd, 2015. 100 years from now, where will the sun be? At 9:15, at 2115. I can exactly tell you where the sun will be. But I cannot tell you really what will happen to rain next week in Boston. So that's the problem. There are certain things which are very precise, almost like clock-like. That is what the simple systems are. Simple systems makes us to make predictions 100 years, 1,000 years from now with no problem. But I cannot do that. What will happen to rainfall even 3 days from now? So these systems are different. And that difference must be understood. So that's what this idea of simplicity comes in. Now if I take these noodles and put it in some hot water and then boil it a little bit, I get this. It's a mess. Basically everything got so connected that now I do not know really which one is what. Because it's not linear anymore and they are very intricately connected. And I was talking to Jim that basically, look, everybody you talk about, yeah, this is a complex problem. Because things are connected, things are interdependent, we don't know exactly what affects what. Is Urmia Lake decreasing because of irrigation, or is it climate change, is it drought, is it really over-extraction of water, too many dams? All of these are important. But all of this could not be equally important. The question for us really today is to figure out really how many of these are important and how many of these can we interact and intervene. Just because something is important does not mean that we have any ability to influence that system. A very good example really is California water problem. We'll talk about a little bit. California water problem, there is a serious problem in California water. And then you ask them, what is the problem? The problem is that we are going through drought, we don't have enough water. So water for whom? We have lots of water in Los Angeles and San Francisco, they don't have any problem with water. Now you say, no, water problem really is with almond. What happens with almond? Because all these vegans, they eat almond and almond milk, and each almond takes 1 gallon of water. They are taking all the water. That's not true. If you really go and actually dig in, you find out that almond is not the problem. Then you say, no, the problem really is with alfalfa. Alfalfa is a type of basically grass you produce for cattle, and it uses almost 25% of water. It only produces $1 billion of revenue, and California has $730 billion. So why are we using that much water for alfalfa? They are to be blamed. No, that's not the problem. The problem really with all these environmentalists really. So they are basically taking out all the water. So there is simply no, even in California you can decide what the source of the problem is. That is where the complexity is. So what we are trying to do, at least force you to think that, look, these are not really like very simple linear problems like the noodles on my left side, but it is a mess. The question is basically how do I start going through that mess? So to do that really, so what I said that like this is what we do really in our water diplomacy framework, that look, how we think about this problem is very important, and we are trying to synthesize our theory and practice. We start with something we're calling that, what are the values that I'm trying to promote? Is it really the water for urban development? Is it water for irrigation? Is it water for human consumption? What is it for? Unless we decide on that particular values, we cannot decide really what is basically bothering me really. That is what we're calling this interest really. What is my interest in this particular problem? And then we talk about tools. The way we think about this really, we have to first discuss, why is this a problem? Why do we have a problem for the Urmia Lake? Urmia Lake has been there for the last several thousand years. The problem has become severe over the last 50 to 100 years. What happened? Are we using more water for irrigation? If we are really, do those farmers have right to use more water than, for example, keeping the lake alive? Why is lake important really? Is fish more important than farmers? Those are the important questions you have to ask. So know why, and then we go back. Know how. What I argue really, I think in most cases, we are spending a lot of time what to do, without even asking what is the problem. What is the problem with Urmia Lake really? Is the problem over allocation of water? Then we need to find out what the solutions are. Rather than doing this, we are just trying to find out the solutions. So what I would encourage all of us to really think about, first think, why am I doing this? Why am I even interested in the Urmia Lake problem? Then talk about really how to address this problem. So first task for us will be probably for next 6 to 8 hours is to at least try to identify what the problem is. And with this really I'll pass it over to Dr. Morid and give us some contextual knowledge, because the first few presentations were kept that way. And then Shurush will join us at 11:20. He is originally from Iran, and he is one of the dominant hydrologists, member of National Academy, very well respected. I know him for almost 30 years now. So I'm glad that he will join us at 11:20. He will provide us with a perspective from natural, climatic, and hydrologic perspective. But before that, we want to hear real on-the-ground knowledge. Dr. Morid.
Thank you very much, Shafir. Thank you. And we are going to have a next first presentation about the past, present, and future of the Urmia Lake.
Okay, thank you very much. The topic of my presentation, as it has been asked for me, is the past, present, and future of Lake Urmia. Unfortunately, the number of slides is a little bit too much, and I will have a problem to finish it. Okay, this is the Lake Urmia, and the basin is located in northwest of Iran with a total area of about 52,000 square kilometers. This is the largest lake in the country and is also one of the world's saliniest bodies of water. The political boundary of the province includes 3 provinces: East Azerbaijan, Kurdistan, and West Azerbaijan. There are lots of economical activity that are going on in the basin: agriculture, food industry, and also from urban point of view, it is very important, and more than 5 million people are living in this area. Tourism is one of the main activities over there, or at least used to be one of the main activities over there. It's a splurge that was very good for treatment of skin, and people came there to for skin treatments. For some years, it was when I saw this picture, I couldn't believe this is Urmia Lake really, and it's a seaway that lots of navigation were going on here between West and East Azerbaijan. And also it is very important from environmental point of view. And we have there Urmia, that is a main feed for migrating birds that goes to Siberia. And also it is one of the Ramsar sites and also UNESCO Biosphere Reserve. Unfortunately, from 1994, almost these times, the lake started to shrink, and now it is in the worst situation at least during the last past century. This is really the problem that makes us very worried about the area is what happened in Arar Sea that caused lots of health problems for the people, and one of the threat of shrinkage of Urmia Lake will be the health problem for because of the possible salty winds and dust storm over there that can make problem for the people. Of course, it will hurt the industrial and other activities too. This is the new situation of the bed of the lake that almost completely dried, and as I mentioned before, dust storm that now we are having there. Okay, let's see what happened over there and how we can quantify the impact of change in land use and change in climate variables. We try to quantify somehow this issue because everybody knows these are the main drivers. But this is I think this is the first work that we try to quantify impact of these drivers. Okay, let's see the land use map of the Urmia Lake. It is 1987 and this is 2007. Between this, during this period, 137,000 hectares had increased to irrigated area. And unfortunately, most of it is because of the orchards that uses lots of water. And in case of precipitation, we have a negative trend in many of the stations over there. You can see here, the red triangle shows the significant decrease of precipitation in the area. And also this is the status of temperature that almost in all of the stations we have increase in temperature. This shows better the status of temperature. You can see increasing trend and also decreasing trend in precipitation and increasing trend in the temperature. Okay, to quantify and define our methodology, we work on some of the papers, and there is a review in this regard that how we can, separate impact of climate variability and human activities on stream flow discharges. There are mainly two methods that are used for this such studies. One is using data-driven models, and one is conceptual model, and we decided to use conceptual model. For this, we use SWOT model that the main inputs are land use for this model and climate data, so we could somehow detrend the climate variables and then use different land use to see impact of these changes on stream flows. For this, we use about 57 hydrometric stations and 25 rain meteorological stations. We calibrated model with the observed discharges as well as changes that we made in the source code of the SWOT model to be able to simulate lake level lake level and volume of the lake, time series of the volume of the lake as well as lake level. And you can see, the results of our work. This is the observed lake level volume, and this is what we have simulated for this period, 1988 to 2007. Okay, so we determined the climate variables, we fixed the land use by 1986, and then we ran the calibrated model and modified model of SWOT for this study. Okay, unfortunately, the methods that are introduced for detrending of climate variables are a little bit different, and you can see how their impacts on the stream flows. What you are seeing here is the volume of the lake from 1966 to 2008, while we are fixing the land use of 1986, and we detrending the climate variables. Okay, and you can see using different methods, we will get different results for this. For that, we compared lake level of Urmia and Van, which are very close together. As you can see, they have had very similar behavior up to 2001. And after this period, you can see different behavior from the two lakes. So we suppose that if we didn't have these changes, still we could have similar behavior of lake and Van together. So we added the Van level, lake level on the previous results, and you can see the closest result was this blue one that uses linear detrending method for detrending of climate variables. Okay, now using those the selected method for detrending the climate variables and the land use of 1986, you can see how we can define different scenarios to see impact of these changes on the lake level. The red one is what we have observed during this. This is the observed data. This one, S2 scenario, is that we just fix the land use and let the observed climate variables to be used. And the green one is using the detrended climate variables and let the land use changes for this period. And the last one, S4, is without any changes. I mean, no changes in land use and no trend in climate variables. And the result shows that if we had this situation, no change in land use and no change in climate variables, and then compare this situation with what we are having now, we can attribute 45% of changes of the lake to human activity and 56% to climate variables. So almost both of them are have been very, affected the lake level. Okay, let's see what have done to save the lake. It almost started from 2010 with the first serious attempt to save the lake was Integrated Management Plan for Lake Urmia Basin, IMPLUB, in 2010, which was initiated by basin stakeholders. The plan was facilitated with UNDP and was approved by central government. The most important agreement in this plan was to allocate 3 billion cubic meter of water per year to the lake, and this amount could bring the lake level to 1274.1 mean sea level, which is the ecological lake level. And quota of each province were indicated in this plan. And to promote the ability of that integrated plan to address consequent water shortages, especially in the agricultural sector, A sub-project was defined by CIW, this is the environmental department. The sub-project indicated how basin agriculture and lake water requirements should be managed in normal and drought situation, and in a leveling plan for each situation, it was indicated how much water should be allocated to the lake and how much water should be allocated to agricultural sector. And these are the options that was introduced in that plan to meet the agricultural demands. If we could follow that program, within almost 20 years, we could reach to the ecological level of the lake, considering allocating that amount of water, 3 billion per year. That is not an easy task. Unfortunately, this program was not that much successful because of the, while cutting farmers' water rights, there would be lots of social and political tension, and maybe one of the lacks of that program was that program didn't have a specific relief program to compensate farmers' losses and getting their contribution for this issue. Okay, in the new government, 2013, the new government approved establishment of a program titled Urmia Lake Restoration Program, using the capacity of Iranian constitution for addressing very important issues. The new program emphasizes on new sources of water for the lake by transboundary projects, wastewater treatment, reduce in agricultural water requirement, reduction of evaporation from the lake's water body. These are the main, outcomes of that program. That is transfer of water from Zob and Silve rivers. This is what is expected in this program for wastewater treatment that can be directly diverted to the lake, and about 40% in agricultural water saving. That is not an easy task, and also those measures that can reduce evaporation in the lake. According to this program, they are optimistic up to 2006 they can reach to a stabilization period. This is considered as a stabilization period, and this is the restoration period, and this is the in 2030 they optimistic to reach to the ecological level that I mentioned, 1274, and hope that they can get such a area by this program for the lake. Okay, what they have done so far in the new government? Actually, they have released. They have defined some specific release of the dams exclusively for the lake. For instance, in 2015, they released 75 million cubic meters for the lake exclusively from Bukhan Dam, and some other releases from Saruk and the Hassandu Dam. And these are the impacts of those releases that you can compare the status of lake before and after these releases. And also dredging the main feeding rivers to the lake, that are these rivers and also Ajichai over here. And also transfer of water from Simine from this river to, this is Zarine route and this is Simine route. Transfer of water from this river to reduce evaporation from the lake. Yes, as you see, when we have released from Zarine route, the water is spread over the lake's bed, and we have lots of evaporation. And because of it, they diverted the water to Simine to reduce the evaporation. This is what is the aim of this project, and this is the construction efforts that were done to for this diversion. Some other works are going on now to stabilize the bed of the Lake Urmia. This is mainly because of dust storm control that I mentioned before, and also grazing management. This is the transfer of water from, I think it is, yes, Silver Dam, that 190 million cubic meters are considered to divert water from here to exclusively for Urmia Dam, and they have accelerated the construction of the dam to, divert water. And embayment of the lake is also considered, and one measure that we reduce the lake area. This is also considered. However, they have some objectives about it also. Okay, because as I mentioned, all the these efforts are to reduce evaporation from the lake, and also some international attempts are going on, FAO and also JICA. Okay, this is the last slide that future of Lake Urmia, in spite of lots of efforts that are going on to save the lakes. Still, I believe we are not in a very what should I say? There are lots of uncertainty that really we can save this lake or not because of this requirement. That is not an easy task to save such a huge of water for the lake per year. Okay, thank you very much.
Thank you very much. Unfortunately, we have no time for questions. For more elaborative questions, we will have enough time after the break in the roundtable discussion. I'm pleased to invite Dr. Rosa Lag, a senior expert from the Urmia Lake Restoration Program, to give her presentation.
Okay, my topics for presentation is sedimentology, hydrogeochemistry, and brine evolution of Lake Urmia. As Dr. Moritz said, completely physiographic of Urmia Lake, I want to show that the depths of Urmia you can see the maximum depth of Urmia is 14 meters, and average of depth is 6 meters depth. But nowadays we don't have these depths, and maximum depth is 2 meters, only 2 meters. For my topic, we work about the paleoenvironment, sedimentology, and hydrogeochemistry, and also mineralogy. That we want to distinguish why Urmia Lake was drying. Our method is in two categories: sediment and water, brine. For sediment, we sample and coring 200 meters cores, and with sampling brine, also chemical analysis, grain size analysis, and determination of economical potential of sediment. Also, for water, we took some samples from 2007 up to now, and we analyzed chemical analysis and also ICP analysis. Okay, you see, we want to look past the past of Urmia, present status, and future of Urmia Lake. As you know, less than 20 years, Urmia Lake reduced the water up to 7 meters that you see here. And you can see the progression of coastal zone from here to here. And we lost 2,000 cubic meters of square meters of lake. We study climate effect, also study causeway impact because we established one causeway from west to east of Urmia Lake. And also a study of bad water management in this area. For a study of climate effect, we process current 55 years period, also 1,000 years before present. In this picture, you can see the water table fluctuation depended on precipitation up to 2000. After 2000, precipitation were better than previous years, but water table falling. Why? Why the precipitation is better, but water table falling? We took some course for reconstruction of the climate in the past, the 20,000 before present. We took some course, you can see the network for sampling, core sampling. Maximum depth of cores is 10 meters. In this picture, you can see we have lake sediments up to 6.5 meters. And the first drought for Urmia Lake is 6.5 meters, about 13,000 before present. We have a completely drought in the Urmia Lake. So we show that the climate change, it is not more important effect for drying Urmia Lake. And we have other factor for drying Urmia Lake. We have 88,000 wells around the lake, and water ground that inflow into the lake with a spring. We have we had very huge springs in the surface of the lake, but nowadays we don't have any spring into the lake because of the 88,000 wells around the lake. Also for river, all of the river, the most of the river, we had a dam. So we don't have enough water inflow to the lake. And causeway. They want to build a causeway such as the bridge. There is a good idea for the closed basin. But after construction of the causeway is the same as Great Salt Lake Causeway. This is very bad thing for the Urmia Lake because of the rate of sedimentation is more is the higher than before, and for about geotechnical problem for the upwelling the sediment in the lake. So the causes of the lake drying is agricultural development and causeway construction, also dam construction, and at the end is climate change. For hydrogeochemistry, we took some samples from the all spring, all wheel, and all river around the lake. You can see the HCO3 and Ca in the water catchment dominated, and you can see the diagram for the all river around the Urmia Lake. For the anion and cation, you can see Ca is more anion, cation, and HCO3 is bicarbonate is the dominate anion. And we give some brine from the Urmia Lake from 2007 up to now. You can see the Na sodium and color dominated, but after sodium and color increase, we have some highlight in the bottom sediment. So Na or sodium decrease, and Mg increase. This is the brine evolution. And in the Piper diagram, you can see the type of brine from 2007 up to 2012, from decreasing of color and increasing of sodium. In the famous diagram, Hardy and Egoster 1978, you can see the path for brine type of Urmia Lake is same as Great Salt Lake in the path 3. Path 3 is bicarbonate, dominate, and is more than Ca plus Mg. But nowadays, the brine of Urmia Lake is MgNaCl brine. The type of brine changes from Na Mg color and to MgNa color. And in this diagram, Warren 2001, you can see the current status of Urmia Lake is here. Density is more than 1.29, and Britain salt were precipitated. So if we want to restoration of Urmia Lake from here to ecological level, we have to change salinity more than 3,050 per 50 gram per liter to maximum 250 gram per liter. It is very difficult for us because we have enough water to the lake. So in the present status, physiography and geomorphology of Urmia Lake completely changed, and the lake changes to a playa, and we don't have any lake. We have a playa, so we don't have enough accommodation space for brine, accommodation space for water because of the sedimentation. During this time, we have some carbonate sediment and also sulfate sediment, such as gypsum, and evaporate sediment. Halite is dominated in the evaporate sediment, and very high gravity brine in the surface. This is the geomorphological of the playa, Urmia playa. You can see ephemeral lake, and also salt pan, saline mudflat, and mudflat. This is a classical geomorphological of a playa, and this map produced by GSI, that geomorphology unit map. You can see the some picture from the area, saline mudflat, ephemeral lake, and salt pan. This is the point. This point of are the depths of Urmia Lake. You can see the maximum depth is a bridge of causeway up to 2,000 centimeters. This is for 2014, but 1 month ago we don't have this depth. The depth decreasing about 35 centimeters because of the precipitated of the salt. Okay, what is the solution? Somebody said there is no solution for restoration of Urmia Lake, so there is no good way for restoration of the Urmia Lake. Somebody said the water it's better than some water from the other basins, such as Van, Caspian Sea, or Sevan, go to the Urmia Lake, and we say that it's better we reduce the salinity of the brine, and it's better we pump the brine and gave some salt from the brine and back to the Urmia Lake. So we took some samples from the salt, also some sample from the brine, for distinguish the chemical characteristic of the brine. Our objective for this suggestion is reducing of salt percentage, controlling and preventing salty dust, and restoration of living Artemia, and so on. For technical section is sampling of brine salt, and also laboratory analysis, and also we took some 1 meter salt, and analysis every 10 centimeters of bottom of salt in 6 areas. You can see the area that we work about the chemical analysis of brine and salt. So after that, we go some brine to the artificial pool. And we monitoring the changes of the brine every day. You can see the diagram for the changes of color, sulfate, also magnesium, color, and sulfate. You can see in magnesium increasing during the evaporation, but potassium at first increase, but after that decrease, and sodium decreasing during the evaporation. You can see in the 10 meters of surface of salt, magnesium is increased, potassium increased, also lithium, but Na is decreased. So nowadays, brine and surface of the salt is high potential for economical production for magnesium, metals, and also potash. And for 6 areas, we distinguish the status of iron in Kalantari Port, Rahmanlu, Kazem Khandashi, Sharaf Khane, and Chiches Port. We have other activity in GSI, saltwater intrusion in the fresh water, also water transfer from Caspian Sea to Urmia Lake, that it is bad idea because of the very different geochemical characteristic between Urmia Lake and Caspian Sea. Also for medical geology in the Urmia Basin, and geophysics, airborne geophysics, and geophysics of the plain. You can see the saltwater intrusion in the fresh water. Also geophysical acquisition of Urmia. You can see some profile. And airborne geophysics. This is the some data, initial maps from the airborne geophysics of Urmia Lake. And we gave some very good result from the airborne geophysics about the thickness of soft sediment in the Urmia Lake. Thank you for your attention.
you very much, Dr. Lek. As you know, the Iranian team had an opportunity to visit the US West to get more experiences about the water and environmental management in US West. I'm pleased to invite Dr. Morid to share his experiences with us in 15 minutes.
Okay, once again, hello. Actually, we had a travel, to some of the lakes in the west of the California, United States. The program was environmental and water resources management issues of inland lakes, sharing experiences and opportunities from Iran's Urmia Basin and the Southwest USA. The program was partly supported by U.S. State of Department. These are the lakes that we visited. We started with Salton Sea and then Owens, Mono Lake, and then Great Salt Lake. You can see here the difference between the area of these lakes and Urmia. We had Mono Lake that was about 1% of the Urmia Lake, and we had Great Salt Lake, which is 84.5%. Okay, I start with Salton Sea. The problems that Salton Sea has is a reduction in inflows, increase in salinity and aurosate, reduction of lakes bed, susceptibility of dust storm, and decline in ecosystem and tourism, and possible conflicts of agricultural sector and natural environment. These are the problems over there, and you can see some of the problems that they had, and of course some of them have been rectified in Salton Sea. This is the southern part of the lake that is already dried and is going to be a little bit worse. Okay, the main reasons for such a situation in Salton Sea is continuous drought and climate change, implementation of agricultural water-saving measures, which led to less water drainage into the lake. The saved water is currently being sold to San Diego. Lack of an integrated perspective in the water management of the region, and all of them are similar in case of Urmia Lake. The main measures that have been taken to sort out the problem of Salton Sea is embayment of the lake, and they are going to reduce this brine part of the lake and establish new marshlands over there to enhance some of the previous lake services. Differences between Salton Sea and Lake Urmia. When I say SS, I mean Salton Sea. SS still has good water resources to being located upstream of American Canal. Still no serious limitation to meet the agricultural water demands. Good budget, however, still low for significant construction projects. Bigger land use, less owners, and possibility for better management. More support of SS due to surrounding agricultural economy. SS facing lower salinity problem. Better institutional arrangements comparing with Lake Urmia. Lesson learned from Salton Sea for Lake Urmia. High regulation to withdraw excess water and control application of chemical material in agricultural sector to preserve the lake's ecology. Good collaboration between universities and establishment of Salton Sea Research Center in the basin. Potential to define new services in and around the lake, like geothermal, power plant, and tourists. Good collaboration and relation between stakeholders in SS that can be useful for restoration of Lake Urmia. This is Owens Lake that it is already dried, and actually there is no more lake over there. The problem is reduction of the lake bed and very, very serious national environmental problem due to being the source of dust and salty storms. The main reason continuous drought and climate change. It is fixed for everywhere. And transfer of lakes influence to Los Angeles. Again, it is similar for Lake Urmia, only we don't have transboundary activity in Lake Urmia. These are the main activities that are now going on in Owens Lake. The main measures to manage the lake is no plan for, okay. There is no plan for restoration. I mean, they are not trying to, restore the lake. Only they are controlling the concentration of activities are on dust storm and saving part of the lake for habitats too. Especially, there are some birds that are important for them. Very extensive monitoring is there, and there is even drones to control the dust and, salt. Difference between Owens Lake and LU, very good financial support of LA Water and Power Department. Ownership of the lake and surrounding land by, again, Los Angeles Water and Power Department. No controversy with traditional land owners that we have such a problem in Urmia. Much smaller volume and no agriculture sector nearby to have conflict with them. Lesson learned from Owens Lake for LU. Very well managed by Owens Lake Dust Project. Presence of a common understanding that it is not possible to fully restore the lake, but rather to prevent negative consequences of the new status of the lake. Good collaboration between different organizations and university. Mainly, we saw Desert Research Institute over there. Application of variety of methods for salt mining in favor of dust control, gravel, clay, and so forth. Application of variety of dust control measures, implementing measures with long lifetime and less water consumption. Continuous allocation of water to Owens Lake even during the drought. It was very interesting for us. Mandatory involvement of water users in the lake. A restoration program. I think they told us $90 they are charging users to support those activities that are going on in the lake. And good grazing control in the lake and surrounding area. In case of Mono Lake, the problem was reduction of inflows, increase in salinity, and reduction in the lake's bed and ecological threat of the lake. The main reason, again, drought and climate change, and again, transfer of lake's inflow to Los Angeles. Similarity with Lake Urmia, all except that we didn't have transfer of water. Okay, one of the things that was very interesting for us was involvement of judiciary over there. After a lengthy battle in and out of the court, the State Water Resource Control Board mandated a return to a specific lake level. As you can see, the lake, I think, went down up to this level, and the court mandated them to bring it to this level, and today it is almost this area. Really, we can categorize this activity as restoration. Again, difference between Mono Lake and Lake Urmia. Owens Lake has much smaller volume and no agriculture sector in the nearby area. Lesson learned, role of NGOs in the lake restoration. It was very interesting that NGOs were very active over there, engaging about 16,000 people, national and international, to support the lake. Systematic work of preserving the circle of life in Mono Lake. They have considered all the elements, algae, birds, brine fly, Artemia, and migrating birds together. The positive role of judiciary system, sentencing LA to return the Mono Lake level, Mono Lake's water. However, if this sentence would have resulted in a lack of drinking water in LA, it would have been voided. So since it couldn't make problem for drinking water, they did such action. Recognition of the ecological values versus the drinking water values. This is the Great Salt Lake that is very similar to Urmia Lake from from the area and shape. The problem of Great Lake is, the lowest lake level since 1960s. This is the current situation of Great Salt Lake, and there is a long distance between the previous ports and the water body of the lake. An increase in salinity. Again, continuous drought and climate change and increase in water demand. All is similar in case of LU also. Differences between GST and LU. GST still has good water resources and lakes problem is at its initial stage. However, if it is not considered properly, future of LU is waiting for GSL. Still no serious limitation to meet the agricultural water demand. Active NGOs, they have an NGO namely Friends of GLS. However, no farmer is a member. I asked them, do you have any member from farmers? And they told us no. Okay. Very active economy in and around the lake, salt mining, mineral mining, and shrimp culture, recreation, with turnover of $1.5 billion per year. That can be very good support for the lake. Lesson learned, operational bioeconomics of GLS. As I told you, lots of activities are going on there. Good collaboration with university, especially Utah State University. Good monitoring with financial support of the shrimp industry. Starting and development of long-term plans for GLS. Okay, conclusion. The current efforts for the above-mentioned lakes should mainly be identified as a strategy to redefine lakes ecological services rather than a lake restoration program, except in case of mono lake. In others, they were trying to control it. They couldn't, bring back the lake level to its previous situation. This has been done with respect to the realities of climate change and increase in water demand. The reduced environmental funds are mainly allocated to drinking and industrial sector with very high revenues. This has been a financial source for the aforementioned strategy. This strategy can be widely considered for Lake Urmia. The severity of water shortage in the above-mentioned lake is minor comparing with Lake Urmia. Therefore, there is no serious challenges between the water users and water managers, at least at this stage. But I believe, especially in case of Great Salt Lake, they are, in initial stage of such a conflict. While in case of LU, the severity of water scarcity and its consequences are higher. In water resource management of visited basins, there is more work being done on controlling water consumption. There were not noticeable measures in favor of decreasing water consumption and increasing inflows to the lake, except in case of mono lake. The current measures of the above-mentioned lakes management are based on master plan, which is also enhanced with simultaneous research activities. Such a plan and collaboration can definitely accelerate the management of LU. The promising actions are going on for monitoring and measurement of crucial variables of the above-mentioned lakes. LU has its own monitoring system. However, it needs to be immediately improved and updated. This is the last slide, and this is very, I'll always use such a slide when I'm talking about climate change. Fortunately, the above-mentioned lakes have not had serious controversies between social water use and environmental preservation so far. However, if this occurs, social water will be favored above mentioned lake. This is a threat for all of the lakes and wetlands in the world. Therefore, there is a crucial need to change the human life system in response to climate change and growing water demand. Otherwise, the tragedy of dried lakes happens for other lakes sooner or later. We had Aral Sea, Noah, Urmia, and Owens that have already gone, I think in case of Chad also. And I think, to address the point of Professor Shafiq, until we cannot, we have not worked on these three words, human lifestyle, this is the, waiting for every, for environment. Thank you very much.
Thank you very much for sharing your experience in visiting SDS.